The idea that 1 dog year equals 7 human years is a mathematical myth. By the time a puppy celebrates its first birthday, its cells have already reached the biological equivalent of a 15-year-old human teenager. If the math we have used for decades is entirely wrong, we have to rethink how long our dogs actually live and look at how scientists are accurately measuring their true biological age. On average, the biological baseline for a dog's lifespan sits between 10 and 13 years, though recent long-term studies show the median creeping closer to 15. But that baseline has extreme outliers. An Australian cattle dog named Bluey holds the absolute record, surviving to an incredible 29.5 years. This massive variation between the average and the extreme suggests that canine aging isn't a fixed clock, but a biological process that fluctuates significantly based on factors we are only just beginning to quantify. To find a mathematically accurate conversion formula, researchers at UC San Diego mapped the molecular changes in canine DNA over time. Graphing human versus dog age reveals a core difference. Humans age linearly, dogs age logarithmically, maturing rapidly before plateauing. This yields a new equation: 16 times the natural log of a dog's age plus 31. Therefore, a 10-year-old dog, 16 times 2.3 plus 31, is biologically 68. The math proves that a dog's biological clock operates on a completely separate timeline from ours. Time degrades their cells at a distinctly different rate. But equations are only half the picture. Genetics and physical size act as massive biological variables that dictate exactly how long a specific dog will survive. As a general rule across the canine world, smaller breeds outlive large ones, and mixed breeds tend to outlast purebreds. There are, however, tragic exceptions to the small dog rule, like the French mastiff. Humans selectively bred these dogs to maximize their large, heavy, wrinkly heads. That exact genetic tampering inadvertently saddled them with severe breathing and heart complications. Because of those specific genetic bottlenecks, the mastiff has the shortest lifespan of any breed, averaging just 5 to 6 years. To decode massive discrepancies like this, an ongoing national study called the Dog Aging Project is currently tracking canine genetics, environments, and lifestyles across the country. A dog's lifespan is heavily dictated by centuries of human-driven selective breeding. This makes our pets a highly specific biological case study. The Dog Aging Project is backed by millions of dollars in research funding, and veterinary medicine is actually the secondary objective. Scientists view dogs as the ultimate biological proxy model for studying human aging. The proxy works because our pets share our exact environment. They live in our homes, breathe the same air, and adopt our daily lifestyle habits. As a result, they suffer from the exact same ailments that we face later in life, including obesity, diabetes, and arthritis. Because dogs naturally age much faster than we do, they act as a biological fast-forward button. Researchers can track a lifetime of disease progression and physical decline in a fraction of the time it takes in humans. By identifying the specific genes and environmental factors that keep dogs healthy, the study aims to do more than just add years to a pet's life. It provides the comparative data necessary to slow the progression of these same diseases in humans.